Look up at the night sky. To the naked eye, it presents an illusion of absolute stillness, a vault of ancient, unchanging light. But that serenity is a lie. If you could see the universe as the instruments of our most advanced observatories see it, you would not feel peace. You would feel a profound, suffocating sense of vertigo. For nearly a century, we have known that the cosmos is expanding. We accepted the unsettling fact that the galaxies are drifting apart, carried outward by a phantom pressure lurking in the absolute vacuum of space. We gave this ghost a name, mapped its steady, relentless push against the immense gravity of galaxy clusters, and built our entire modern understanding of reality upon its assumed permanence. Physics demands consistency to make sense of the world. We believed the rules of the dark were settled, fixed, ever since the fading echoes of the Big Bang. We believed the underlying engine driving the universe had a single, unbreakable, constant gear. But something deeply unsettling is hiding out there in the cosmological dark. Over the last few years, the James Webb Space Telescope opened its hexagonal golden mirrors to peer further back in time and measure the grand architecture of the cosmos with unprecedented, almost terrifying precision. It was deployed to confirm our foundational models. It was supposed to finally tie a neat mathematical bow around the standard model of cosmology, locking in the age and the ultimate trajectory of existence itself. Instead, the raw telemetry beaming back to Earth across 1,000,000 miles of freezing vacuum is quietly fracturing everything we thought we knew. The numbers are entirely wrong. The speed at which the fabric of reality is stretching does not match the ancient blueprints of creation. There is a violent tension in the data, a glaring, mathematical discrepancy that simply cannot be explained away by instrument error, cosmic dust, or statistical noise. The universe is not just expanding, it is behaving as if something fundamental, something buried deep within the absolute shadows of empty space, is waking up, shifting, and altering its very own nature as the eons pass. If you are fascinated by the terrifying grandeur of the cosmos, if you seek the cold truth hiding in the dark, and wish to explore the mysteries that keep physicists awake at night, subscribe to this channel and join us on this journey. We do not offer comforting lies here, only the magnificent, indifferent reality of the void. This anomaly in the Webb data points to a fatal flaw in our most basic comprehension of space and time. To truly grasp the sheer scale of the terror staring back at us through the telescope's lenses, we must first completely unlearn the universe we thought we lived in. We must look back to the exact moment humanity first realized the sky above us was not a glass ceiling, but a runaway train. Human intuition is a highly specialized, tightly constrained biological tool. Our brains evolved over millions of years to calculate the parabolic trajectory of a thrown spear, to gauge the velocity of a predator rushing through tall grass, and to understand the immediate, localized physics of stones, water, and friction. We are creatures of the macroscopic middle ground, completely blind to the microscopic frenzy of quantum mechanics and utterly unequipped to intuitively grasp the staggering, mind-bending scale of relativistic astrophysics. Because of this evolutionary blind spot, we inherently trust our immediate senses. We step outside on a clear, freezing night, look up at the vault of the Milky Way, and we perceive a static, enduring ceiling, a silent museum of ancient fire. For millennia, the greatest intellects in human history fell into this exact biological trap. The assumption of a static, eternal universe was not merely a philosophical preference, it was the unquestioned bedrock of all early scientific thought. Even Albert Einstein, a man whose mind routinely walked outside the boundaries of human intuition, looked at his own revolutionary equations of general relativity and flinched. His equations dictated that gravity, the relentless curvature of space-time created by mass, was a universal contractor. Every star, every galaxy, every drifting atom of hydrogen was pulling on every other atom in existence. In a universe filled with matter, a static arrangement was mathematically impossible. It was the equivalent of a pencil balanced perfectly on its microscopic tip of graphite. Inevitably, it had to fall. The universe had to either be collapsing in on itself under the crushing weight of its own gravity, or expanding outward from some primordial, violent genesis. But the prejudice of a silent, motionless sky was so deeply ingrained that Einstein manually inserted a mathematical fudge factor into his elegant equations. He introduced a theoretical repulsive force, a cosmological constant, perfectly and arbitrarily tuned to counteract the gravitational pull of all matter, effectively forcing the math to match the illusion of a still universe. He locked the cosmos in an artificial, suspended animation. It took less than 2 decades for the cold, hard reality of observation to shatter that illusion completely. High in the San Gabriel Mountains of California, isolated in the freezing dark of the Mount Wilson Observatory Dome, an astronomer named Edwin Hubble spent the late 1920s staring through the massive steel framework of the Hooker telescope. He was looking at distant smudges of light, spiral nebulae that the consensus of the era believed were merely localized, clouds of gas drifting within the borders of our own Milky Way galaxy. Hubble painstakingly isolated individual, rhythmic, dying stars within those smudges Cepheid variables by meticulously measuring the pulsing cadence of their luminosity and comparing their absolute physical brightness against how dim they appeared from Earth. He calculated the true distance to these objects. The numbers were devastating to the established dogma. These were not clouds of gas in our stellar backyard. They were entirely separate, colossal island universes, swirling galaxies containing hundreds of billions of stars, suspended millions of light years away across an unimaginably vast ocean of absolute nothingness. But the sheer scale of the universe was only the first blow. When astronomers analyzed the light bleeding across the vacuum from these distant galaxies, they found a severe, systematic distortion. The electromagnetic spectrum of the light was being stretched. The specific chemical fingerprints of elements like hydrogen and calcium shifted heavily toward the lower frequency, red end of the spectrum. To understand this redshift, imagine standing on a desolate, foggy city street at 3 in the morning. An ambulance speeds past you. As it approaches, the sound waves of the siren are compressed, raising the pitch into a piercing wail. But the moment it passes and speeds away into the dark, the sound waves are stretched out behind it, and the pitch immediately drops into a low, mournful drone. Hubble was looking at a visual equivalent of the Doppler effect. The redshift of the starlight was the morning drone of galaxies retreating from us at catastrophic speeds. Yet, there is a fundamental misconception about this expansion that plagues our common sense. The galaxies are not flying apart through pre-existing, static space like glowing shrapnel from a cosmic bomb. The space itself, the invisible, intangible fabric of reality lying between the galaxies, is being actively manufactured. Imagine a dense, heavy loaf of raisin bread rising in a dark oven. The raisins themselves are not swimming through the dough. The dough is swelling in all directions, creating more distance between every single raisin simultaneously. The farther apart two raisins are, the more expanding dough lies between them, and the faster they appear to recede from one another. We live inside a rising, boundless loaf of cosmic geometry. For decades following this terrifying realization, the scientific community reached a new, slightly more comfortable consensus. The universe had a beginning. It exploded outward from an infinitely dense singularity, and space has been stretching ever since. But common sense, that stubborn evolutionary relic, dictated one absolute certainty: the expansion had to be slowing down. Gravity is the ultimate tether. The collective gravitational drag of trillions of galaxies, black holes, and vast oceans of dark matter should act as a massive cosmic brake mechanism. If you throw a stone straight up into the night sky, you know exactly what the laws of physics demand. The stone will bleed its kinetic energy. It will relentlessly decelerate as the Earth pulls it back. It might have enough escape velocity to break free of the atmosphere, coasting into the void, forever slowing but never quite stopping. Or it might exhaust its momentum, hang suspended for a brief, breathless mathematical limit, and plummet back down in a catastrophic collapse. This was the destiny of the cosmos, the big chill of infinite, slowing expansion, or the big crunch of a violent, fiery retraction. Deceleration was not just a theory. It was a fundamental requirement of a universe governed by gravity. In the late 1990s, the scientific community finally developed the tools necessary to measure this cosmic deceleration. Two independent, highly competitive teams of astrophysicists set out to map the exact rate at which the universe was throwing on the brakes. To do this, they needed a specific kind of measuring tape. They needed objects incredibly bright, perfectly consistent in their luminosity, and visible across billions of light-years of dead, expanding space. They found their perfect cosmic yardstick in the violent deaths of white dwarf stars. These events are known as Type Ia supernova. Their mechanics are morbid, precise, and breathtakingly violent. Picture a binary star system, a dense, glowing corpse of a dead star locked in a tight, spiraling gravitational embrace with a massive, living companion. The dead white dwarf acts like a celestial parasite, its immense, localized gravity siphoning off a relentless, swirling stream of hydrogen and helium from its living partner. But the dead star is bound by an unbreakable law of quantum mechanics. It is held up against the crushing weight of its own gravity entirely by electron degeneracy, pressure, the absolute refusal of its subatomic particles to occupy the same quantum state. However, there is a strict mathematical weight limit to this resistance. It is called the Chandrasekhar limit, and it sits precisely at 1.44 times the mass of our Sun. The moment the stolen matter pushes the white dwarf a fraction of a milligram past this absolute limit, gravity instantly wins. The star violently collapses inward, triggering a catastrophic thermonuclear runaway reaction. It does not simply burn, it unzips its entire atomic structure in a fraction of a second, detonating in an explosion that outshines the combined light of an entire galaxy. Because the trigger mechanism of this detonation is dictated by a strict, unyielding law of mass, the resulting explosion always yields the exact same absolute physical brightness. They are standard candles. They are the equivalent of a perfectly calibrated 100-watt light bulb placed in the absolute dark, halfway across the observable universe. The astrophysicists aimed the world's most powerful telescopes deep into the oldest, blackest patches of the sky, hunting for the ghostly afterglow of these specific detonations. The methodology was elegant. By measuring the redshift of the host galaxy, they knew exactly how fast the galaxy was receding away from Earth. By measuring how faint the supernova appeared in their lenses, they knew exactly how far away the light had traveled. Speed and distance. Plot the coordinates, calculate the gravitational drag, and finally discover how fast the universe was slowing down. When the raw data began to filter back through the mainframe computers, it did not look like a scientific breakthrough. It looked like an instrument failure. It looked like a catastrophic software error. The light from the most distant, ancient supernova was wrong. It was incredibly faint. It was roughly 25% dimmer than the most conservative, gravity-heavy models predicted. The teams spent months agonizing over the telemetry. They accounted for microscopic cosmic dust obscuring the lenses. They modeled the chemical evolution of ancient stellar formations. They ruthlessly audited their own mathematics. But the terrifying truth remained burned into the digital readout. The light was faint because the dying stars were vastly further away than they had any physical right to be. The stone thrown into the night sky was not slowing down. It was accelerating. It was as if you threw a rock upward, watched it climb against the pull of the earth, and then, halfway to the clouds, it suddenly, inexplicably, slammed its foot on an invisible accelerator, rocketing away from you faster and faster, tearing up into the freezing void of space with a violent, exponential surge of power. The expansion of the universe was not bleeding energy, it was gaining it. Some unknown, phantom pressure was pushing from the inside out, overpowering the combined gravitational anchor of every galaxy in existence, actively stretching the vacuum of space at a constantly accelerating rate. Physics abhors a vacuum, but it abhors an unexplained phenomenon even more. To prevent the entire standard model of cosmology from collapsing under the weight of this impossible observation, theoretical physicists were forced to reach back through history and resurrect Einstein's greatest blunder. They took his discarded cosmological constant, his mathematical fudge factor, and weaponized it to explain the acceleration. They gave this phantom pressure a name: dark energy. It is a terrible, highly misleading name. It is not energy in any conventional, tangible sense. You cannot harvest it. It does not radiate heat. It does not interact with light. It does not cluster around black holes or form matter. It is entirely invisible to every sensor humanity has ever built. Dark energy is, as far as the mathematics can describe, an intrinsic, structural property of the vacuum of space itself. Empty space is not nothing. In the complex mathematics of quantum field theory, a pure vacuum is a violently boiling sea of virtual particles constantly snapping into and out of existence. Space has a cost. It possesses an inherent baseline density of energy, and this leads to a horrifying runaway thermodynamic paradox. Unlike a tank of gas, where expanding the volume reduces the density and pressure, dark energy does not dilute. If you take a cubic parsec of empty space and stretch it to twice its size, the density of the dark energy within it remains exactly, stubbornly, the same. More space is created, and therefore, more dark energy is willed into existence from absolute nowhere. This creates an apocalyptic feedback loop. Dark energy forces space to expand. The expansion of space creates more volume. That new volume contains more dark energy. That new dark energy pushes space apart even faster, creating even more volume. A cosmic engine that continuously floods its own cylinders with an infinite supply of fuel, running hotter, faster, and more violently as the eons tick by. This is the cosmological constant, the symbol lambda. It is the invisible, suffocating pillar holding up the entirety of modern astrophysics. The prevailing framework of reality is called the Lambda CDM model, and it relies entirely, unquestionably, on one foundational assumption, that the density of this dark energy is a rigid, unchanging number. We assumed that a cubic meter of pure vacuum today contains the exact same microscopic trace amount of repulsive force as a cubic meter of vacuum did 10 billion years ago in the chaotic aftermath of the Big Bang. We accepted the terror of a runaway universe because we believed the ghost haunting the machine was at least predictable. We believed that this dark, invisible hand pushing the galaxies apart exerted a constant, mathematically pristine pressure. The mathematics of general relativity only hold together if this phantom energy never wavers, never evolves, and never changes its fundamental nature over the lifetime of the cosmos. To fully grasp the magnitude of the terrifying problem now staring back at us from the void, you must first understand the chilling isolation and the mechanical perfection of the instrument that finally exposed it, 1,000,000 miles away from the comforting blue glow of Earth, suspended in a gravitational desert known as the second Lagrange point. A colossal structure of kapton and beryllium drifts in absolute, freezing silence. The James Webb Space Telescope is not merely an observatory. It is a time machine built to operate at the razor edge of absolute zero. Unlike its predecessor, the Hubble Space Telescope, which orbits a mere few hundred miles above our atmosphere in the warm embrace of low Earth orbit, Webb sits in a frozen, permanent exile. It is shielded from the blinding thermal radiation of our Sun, the Earth, and the Moon by a massive sunshield composed of 5 microscopic layers of synthetic polymer. It is a structure so delicate it could be torn by a stray pebble, yet so resilient it perfectly blocks the relentless fury of a star. In the eternal, artificial shadow behind that shield, the temperature drops to a deadly, unforgiving -390 degrees Fahrenheit. This extreme cryogenic state is not an engineering accident. It is a brutal physical necessity. Light, as it travels through the expanding fabric of a universe driven by dark energy, is relentlessly stretched. The ultraviolet and visible light emitted by the very first stars, the ancient fires that ignited the cosmic dawn over 13 billion years ago, has been pulled apart by the sheer mechanical expansion of space itself. By the time that light crosses the abyss and reaches our solar system, its wavelength has elongated entirely out of the visible spectrum and shifted deep into the infrared. If you want to see the primordial birth of the universe, you cannot look with human eyes. You must look for the faint, invisible heat of ancient ghosts. And to see that microscopic heat without blinding your own sensors, your telescope must be vastly colder than the dead space it is observing. Webb's 18 hexagonal mirror segments, forged from ultra-lightweight beryllium and coated in a layer of pure gold, barely atoms thick, act as a perfect, unblinking trap for these ancient photons. When Webb finally unfolded in the dark and opened its golden eye, astrophysicists did not just hope for sharper images. They expected a coronation. They expected Webb to look deep into the cosmic architecture, measure the expansion rate with ruthless precision, and finally, erase a terrifying mathematical ghost that had been haunting cosmology for a decade. This ghost is known as the Hubble tension. To understand the existential dread embedded in this innocuous phrase, you must understand how we calculate the fundamental architecture of reality. There are precisely 2 ways to measure how fast the universe is expanding today. A master number, represented by the Hubble constant, mathematically denoted in the equations of general relativity as $h_0. These two methods are completely independent of one another. They use entirely different sets of physics, they look at entirely different eras of time, and they rely on entirely different cosmic phenomena. By all the laws of logic, reason, and mathematics, if our foundational understanding of the universe is correct, these two separate paths must converge on the exact same final number. They are two separate tunnels being dug blindly from opposite sides of a colossal mountain. They must meet perfectly in the dark center, or the entire structural integrity of the mountain is a catastrophic lie. The first tunnel begins at the absolute beginning. It measures the extreme early universe, an era long before stars, galaxies, or planets existed. 380,000 years after the Big Bang, the cosmos was not empty. It was a suffocating, blindingly hot fog of ionized plasma, a primordial soup of subatomic particles where light itself was trapped, endlessly ricocheting off a chaotic storm of free electrons. But as the immense pressure of the universe expanded, it eventually cooled just enough for those electrons to finally bind to protons, forming the very first stable atoms of hydrogen. In that singular epochal moment, the fog instantly cleared. The universe became transparent, and the first light was finally free to travel unhindered through the void. That ancient flash of creation is still washing over us right now, raining down on the earth from every possible direction in the sky. It is the cosmic microwave background, the oldest fossilized light in existence. When the European Space Agency launched the Planck satellite into deep space to map this ancient background radiation, it did not capture a perfectly smooth ocean of light. It captured a universe covered in microscopic thermal scars, tiny, almost imperceptible fluctuations in temperature, varying by mere fractions of a degree. These spots of slightly warmer and slightly cooler radiation are the preserved imprints of immense sound waves, baryon, acoustic oscillations that rippled violently through the primordial plasma before it froze into transparency. By mapping the exact physical size and distribution of these frozen sound waves across the sky, theoretical physicists were given a flawless, geometric blueprint of the infant universe. They fed this ancient blueprint into our ultimate mathematical engine, the Standard Model of cosmology. They took the known ingredients of reality: 5% ordinary matter, 27% dark matter, and 68% dark energy, assumed the dark energy was a perfect, unchanging cosmological constant, $lambda, and let the supercomputers simulate the next 13.8 billion years of cosmic expansion. The model spat out a highly precise, definitive prediction for exactly how fast the universe should be expanding right now, today. The number was 67.4 kilometers per second per megaparsec, a slow, steady, perfectly calculated rate. That was the first tunnel. The second tunnel is dug from our end of the timeline, measuring the modern, local universe through direct, unforgiving observation. This method is called the cosmic distance ladder, because we cannot throw a physical tape measure across the infinite void. We must build our understanding of cosmic scale, rung by agonizing rung. The first rung relies on basic geometry, measuring the parallax shift of relatively close stars as the Earth orbits the Sun. But to reach across the true, horrifying depths of intergalactic space, we must rely on the ticking clocks and exploding bombs of the cosmos. We return to the Kifid variable stars. A Cepheid is a massive, highly unstable star in the agonizing twilight of its life. It literally breathes. The outer atmospheric layers of the star violently expand, letting trapped heat escape, which causes the star to cool and rapidly contract, trapping the internal heat once again in a relentless, rhythmic cycle. The mathematics governing this stellar respiration are beautiful and absolute. The slower a Cepheid pulses, the physically brighter it intrinsically is. By clocking the exact rhythm of a distant Cepheid's pulse, we know its true physical brightness. By comparing that true brightness to how faint and ghostly it appears in our telescopic lenses, we calculate the exact distance to it. They are the golden milestones of the local universe, but even the brightest, most violent Cepheid fades into invisible static when you look deep enough into the expanding abyss. To reach the farthest edges of the observable bubble, we must attach the final, most violent rung of the ladder. We use the Cepheid variables to calculate the precise distance to nearby galaxies that have recently hosted a Type Ia supernova, because we know the exact distance to the host galaxy via the pulsing Cepheids. We can flawlessly calibrate the blinding, uniform light of the supernova detonation. We then use these perfectly calibrated stellar bombs to measure the distances to other galaxies, billions of light-years further out, deep into the darkest, most ancient corners of the expanding void. Step by step, star by star, detonation by detonation, astrophysicists meticulously built a physical, undeniable map of the expanding universe. When they calculated the modern expansion rate using this direct, local distance ladder, they fully expected the final numbers to cleanly align with the predictions made by the Planck satellite's map of the infant universe. They expected to meet the other tunnel in the dead center of the mountain. Instead, they hit empty space. The direct observation of the modern universe yielded a fundamentally different, completely incompatible number: 73 kilometers per second per megaparsec. The universe we directly observe around us is expanding nearly 10% faster than the universe predicted by the ancient blueprint of the Big Bang. At first glance, a discrepancy between 67 and 73 might sound to the layman like a trivial rounding error, a minor statistical squabble among academics. But in the rigid, unforgiving architecture of astrophysics, this is not a cosmetic crack in the drywall. It is a massive, structural fracture in the foundation of reality. The two numbers have incredibly tight, completely incompatible margins of error. In the language of particle physics and cosmology, a discovery is considered an absolute fact when it reaches a statistical certainty of 5 sigma. A 5 sigma event means there is roughly a 1 in 3.5 million chance that the result is a statistical fluke. The discrepancy between the early universe prediction and the late universe observation has long surpassed the 5 sigma threshold. It is mathematically impossible for both numbers to be a mistake. For over a decade, the primary defense mechanism of the global scientific community was absolute, stubborn denial. It is a highly rational defense. Space is incredibly messy. It is choked with microscopic silica dust, shifting clouds of ionized gas, and the chaotic glare of billions of irrelevant background stars. It was entirely logical, almost comforting, to assume that the error lay squarely in human hands. Perhaps we fundamentally misunderstood the chemical composition and metallicity of the Cepheid variable stars. Perhaps the intricate glass lenses of the Hubble Space Telescope were being slightly warped by thermal fluctuations as it passed in and out of the Earth's shadow. Perhaps our calibration of the distance ladder was contaminated by the sheer, noisy chaos of looking through millions of light-years of overlapping galactic debris. The entire standard model of cosmology, the elegant equations of general relativity, the rigid, unchanging nature of the vacuum, all of it was protected by the comforting assumption that our physical measurements were simply flawed. We prayed that the tension was an illusion of bad engineering. This is exactly why the James Webb Space Telescope was deployed. It was the ultimate arbiter, designed to be physically immune to these specific terrestrial failures. Webb's near-infrared camera does not care about interstellar dust. Its long wavelengths cut through the swirling nebulae and atmospheric debris like a medical scan through soft tissue. Its immense, hyper-polished beryllium mirrors gather so much ancient light that the blurry, overlapping crowds of stars in distant galactic clusters are instantly resolved into pristine, isolated, singular points of fire. Over the course of its first observing cycles, a team of veteran astrophysicists commandeered Webb's unblinking golden eye and pointed it directly at the heart of the mathematical controversy. They did not search for new phenomena. They went back to the exact same Cepheid variable stars that the Hubble Space Telescope had agonizingly measured over decades. They went back to the exact same host galaxies of the type Ia supernova. They retraced every single step of the cosmic distance ladder, but this time, they did it with a machine capable of terrifying, almost surgical precision. Month after month, the raw, uncompressed telemetry streamed back to the servers on Earth. The astronomers meticulously plotted the infrared pulses of the Cepheids, stripping away the theoretical noise, eliminating the blinding dust, removing every conceivable variable, calibration error, and optical illusion that could have possibly corrupted the earlier measurements. They expected the numbers to slowly, inevitably, drop. They expected Webb's flawless optics to finally reveal that the local universe was expanding at a sedate 67 kilometers per second, perfectly matching the ancient, cooling glow of the Big Bang. They waited for Webb to restore the mathematical harmony of the cosmos, allowing the ghost of a constant, unchanging, dark energy to rest in peace. But the universe is utterly indifferent to our desire for mathematical harmony. When the final, agonizing calibrations were complete and the supercomputers rendered the definitive measurements of the local expansion rate, the tension did not dissolve into the background noise. It solidified. It hardened from a theoretical, highly debated anomaly into a cold, unbreakable physical fact. Webb's flawless infrared data confirmed the previous higher measurements with a level of statistical certainty that paralyzed the astrophysical community. The local universe is undeniably, unequivocally, expanding much faster than the early universe dictates it ever should. To truly comprehend the violent scale of this discrepancy, you must pause and consider the unit of measurement itself, kilometers per second per megaparsec. A megaparsec is a unit of incomprehensible, suffocating distance. It represents roughly 3.26 million light-years of empty, freezing void. For every single megaparsec of empty space that sits between us and a distant, ancient galaxy, that galaxy is being actively pushed away from us an additional 73 kilometers faster every single second. It is a compounding, relentless, exponential horror. If you look far enough into the cosmic dark, the cumulative expansion of space becomes so violent, so overwhelmingly fast, that galaxies are being carried away from us faster than the speed of light itself. They are slipping over the cosmic horizon, forever erased from our observable reality, their light never to reach our lenses, swallowed whole by the rapidly expanding geometry of the void. Webb systematically eliminated the last refuge of the skeptic. We can no longer blame the instruments. We can no longer blame the obscuring dust of the cosmos. We can no longer assume that humanity made a simple, embarrassing arithmetic error in mapping the distance to the stars. The physical measurement of the modern distance ladder is perfectly, undeniably sound. The measurement of the ancient cosmic microwave background is perfectly, undeniably sound. The two tunnels have been dug flawlessly, straight and true. If the tunnels have been perfectly dug, and the raw measurements of both the ancient cooling plasma and the modern exploding stars are absolutely flawless, then we are forced to confront a far more terrifying conclusion. The error does not lie in our instruments. The error does not lie in our mathematics. The error lies in our fundamental, unquestioned belief about the nature of the dark, intervening space between those 2 points in time. The bridge connecting the infant universe to the present reality is built upon a mathematical lie. To understand the sheer gravity of this theoretical collapse, you must step inside the architecture of the Lambda-CDM model. This is not merely a theory. It is the grand, overarching mathematical engine that humanity uses to simulate the entirety of existence. It is a recipe with highly specific, unforgiving ingredients. We input the raw mass of baryonic matter, the protons, neutrons, and electrons that make up every star, planet, and biological cell. We input the massive, invisible scaffolding of cold, dark matter, the gravitational glue holding the spinning galaxies together. And finally, we input the cosmological constant, lambda $, the unyielding, invisible pressure of dark energy driving the vacuum apart. We take the precise temperature map of the cosmic microwave background, feed it into this mathematical engine, and let the equations of general relativity grind forward through 13.8 billion years of simulated time. If the model is correct, the simulated universe it spits out at the end of the calculation must flawlessly match the real, physical universe we observe through our telescopes today. But it does not. The engine is producing a universe that expands too slowly. The mathematical output is completely desynchronized from the physical reality. Imagine a sprawling, global network of high-frequency trading servers, processing trillions of financial transactions at the speed of light. The entire architecture relies on an absolute, unquestionable synchronization of atomic clocks. If a cluster of servers on one side of the planet falls out of sync by even a fraction of a millisecond, the mathematical logic of the system violently breaks down, triggering a catastrophic, cascading collapse of the global economy. The Hubble tension is the realization that the atomic clocks governing the expansion of space are fundamentally the universe we measure in the deep past and the universe we measure in the immediate present are running on two completely different mechanical rhythms. Theoretical physicists have spent years staring at whiteboards covered in the sprawling calculus of tensor fields and thermodynamic laws, desperately searching for a way to force the two measurements to align. The agonizing truth they have finally arrived at is that there is only one variable left to manipulate. The mass of ordinary matter cannot be changed. The gravitational behavior of dark matter is heavily constrained by observational physics. The only lever left to pull, the only ghost in the machine that can possibly explain the discrepancy, is the cosmological constant itself. We must question the darkest, most mysterious element of the vacuum. For a century, we assumed that dark energy was perfectly rigid. We assumed it was an intrinsic, unchanging property of empty space, mathematically locked in place forever. But what if it is not? What if dark energy is not a constant, dead feature of the vacuum, but a dynamic, evolving, living entity? What if the phantom pressure pushing the galaxies apart is changing its strength as the universe ages? To even entertain this heresy requires breaking down the most terrifying equation in modern cosmology. It is the equation of state for dark energy. In thermodynamics, an equation of state is a mathematical model that describes the relationship between the pressure, density, and temperature of a given substance. For the vacuum of space, this relationship is distilled into a single critical parameter, universally denoted by physicists as the letter $W. This parameter represents the ratio of pressure to energy density within the vacuum, expressed in the formula $W equals frac $, where $P is pressure, $Ho is the energy density, and $C is the speed of light. It is the ultimate diagnostic code for the behavior of reality. For ordinary matter, like the cold dust drifting through an interstellar nebula, there is virtually no pressure relative to its mass, so its equation of state parameter sits at exactly zero. For the chaotic, blindingly fast radiation of photons hurtling through the early universe, the parameter is precisely 1/3, but dark energy is an entirely different, monstrous class of physics. To cause the expansion of the universe to accelerate, dark energy must possess a massive, overwhelming, negative pressure. In the realm of classical physics, negative pressure is an incredibly difficult concept to visualize. If you inflate a balloon, the trapped air exerts positive pressure, pushing outward against the rubber, trying to stretch it. If you let the balloon go, the elastic tension of the rubber exerts an inward force, attempting to violently collapse the space back down. That inward, pulling tension is a macroscopic form of negative pressure. Now, scale that up to the absolute fabric of reality. According to the strict rules of general relativity, energy and mass are interchangeable. Because gravity is dictated by both mass and energy, the massive negative pressure of dark energy behaves like a repulsive gravitational force on a cosmic scale. It actively repels space, and for the last 25 years, the entire global consensus of astrophysics has rested on one unyielding mathematical assumption. The parameter $W must be equal to exactly -1. If $W is exactly -1, then dark energy is a true cosmological constant. It means the energy density of the vacuum remains absolutely static, completely indifferent to the vast, ballooning expansion of the universe. It means that a cubic meter of empty space born tomorrow will possess the exact same dark, repulsive energy as a cubic meter of empty space born 10 billion years ago. It is a universe running on a cold, steady, unchanging motor. But the violently conflicting data pouring in from the James Webb Space Telescope and the Planck satellite suggests a terrifying alternative. The engine is not steady. The parameter $W might be slipping. If dark energy is evolving, we are no longer dealing with a simple property of empty space. We are dealing with a dynamic, universally pervasive quantum field, actively shifting and changing its state over cosmic timescales. Physicists call this hypothetical evolving force quintessence. The name is borrowed from ancient Greek philosophy, the elusive fifth element, an ethereal substance believed to fill the universe beyond the terrestrial sphere. In modern theoretical physics, quintessence represents a scalar field, an invisible energy grid that blankets the entire cosmos interacting with the geometry of space in Wiltum. To visualize this, imagine driving a car at night down an impossibly wide, perfectly straight highway, completely devoid of streetlights. Your headlights illuminate only the few hundred feet of asphalt directly in front of you. For hours, you drive with the accelerator pressed exactly halfway down. You are moving at a constant, predictable speed. You assume the road is perfectly flat. This is the cosmological constant. This is the assumption of a static vacuum. Now, imagine that, imperceptibly at first, the car begins to accelerate. You have not touched the gas pedal. The engine's output remains identical, but the speedometer is creeping up. The only physical explanation is that the road itself is no longer flat. You have crossed an invisible threshold and are now driving down a long, slow, ever-steepening incline in the pitch dark. You cannot see the hill, but you can feel its kinetic consequence as gravity pulls the vehicle forward faster and faster. In the quintessence model, dark energy is rolling down an invisible, cosmological hill. Its energy density is not a fixed, stubborn number, but a dynamic value slowly sliding down a potential energy curve. If this is true, it means that in the ancient, distant past, dark energy was fundamentally weaker. When the Planck satellite captured the thermal scars of the early universe, the scalar field was sitting high up on a plateau, exerting far less negative pressure. The universe expanded, but without the violent, runaway acceleration we see today. But as billions of years ticked by, the field slowly began to roll down the slope, converting its potential energy into kinetic expansion, continuously increasing its grip on the fabric of space. By the time the James Webb Space Telescope measures the modern, local universe, the field has accelerated to a terrifying velocity, actively pushing the galaxies apart with far greater ferocity than the ancient mathematical models predicted. This completely resolves the massive mathematical tension breaking the standard model. The early universe and the late universe yield to completely different expansion rates because they were governed by two completely different strengths of dark energy. The atomic clocks were not desynchronized by a flaw in the system. The mechanism driving the clocks is physically mutating, but the introduction of a dynamic, mutating vacuum comes with a horrifying theoretical cost. If we abandon the safety of a constant vacuum, we are opening Pandora's box. If the parameter $W$ is not anchored precisely at -1, physics loses all ability to predict the boundaries of reality. If the scalar field is rolling down a hill, what happens when it reaches the bottom? What happens if the field loses its momentum, bleeds off its negative pressure, and the parameter creeps up above -1? In this scenario, the dark energy driving the universe is an ephemeral phantom, a temporary phase of quantum mechanics that will eventually burn itself out. The repulsive force will slowly fade, starving the expansion of its fuel. As the cosmic engine stalls, the absolute, immortal grip of gravity will reassert its dominance. The trillions of drifting galaxies will slow their retreat, hang suspended in the freezing void for a brief, breathless eternity, and then begin the unimaginably violent process of collapsing back in on themselves. The universe would end in a catastrophic, infinitely dense crush of superheated plasma and merging black holes. Yet, there is an even darker, more mathematically perverse alternative lurking in the equations. An alternative that the latest, most cutting-edge data from our deepest sky surveys is quietly beginning to hint at. In the last few years, astrophysicists combined the surgical infrared precision of Webb with the sprawling, statistical dragnet of the Dark Energy Spectroscopic Instrument, an observatory tasked with mapping the three-dimensional coordinates of tens of millions of galaxies. They were hunting for the exact historical trajectory of the cosmic expansion. They were looking for the exact slope of the invisible hill. When they crunched the initial data, the mathematics suggested a subtle, agonizing shift in the parameter $W. It was not fixed at -1. It appeared to be fluctuating. But the terror lies in the direction of the slip. Some of the mathematical models suggest that the parameter might be dipping below -1. In the cold, strict architecture of thermodynamics, crossing the boundary below -1 is an act of profound physical heresy. It violates the dominant energy condition, a fundamental mathematical law that ensures the stability of the vacuum and dictates that energy cannot flow faster than the speed of light. A universe where $W drops below -1 is a universe governed by phantom energy. If dark energy is a phantom field, it does not merely push space apart, it feeds on the expansion itself. It creates a catastrophic, infinite feedback loop that defies all rational logic. As the universe expands, a phantom energy field actually becomes denser. The more empty space is created, the more concentrated and violent the repulsive force becomes. It is an engine that inexplicably generates more horsepower the wider you open the throttle, drawing an infinite supply of energy from absolutely nowhere, violently violating the conservation of energy. This is the ultimate barrier. This is the mathematical brick wall where human intuition completely shatters and the equations of relativity begin to scream. We are entirely comfortable with the concept of an explosion, a sudden release of energy that rapidly expands and eventually dissipates into the cold dark. But phantom energy is an explosion that perpetually accelerates its own detonation, growing hotter, denser, and more viciously powerful as the shockwave moves outward. If the discrepancies in our measurements are caused by a mutating vacuum, and if that mutation is trending toward phantom energy, the implications for the physical universe are catastrophic. We are no longer observing a passive, silent sky. We are living inside a ticking biological weapon, a universe infected by an invisible, escalating thermodynamic parasite. The tension between our two greatest measurements of time is not a glitch in our understanding. It is a diagnosis. It is the vital sign of a cosmos whose underlying physics are actively, relentlessly breaking down. And the most terrifying aspect of this diagnosis is what it means for the ultimate, inescapable fate of everything you have ever known, every star you have ever seen, and the very fabric of space itself. To understand the sheer horror of a universe dominated by phantom energy, we must first revisit the fundamental promise of gravity. Since the dawn of the dark energy discovery, astrophysicists have offered humanity a comforting caveat. Yes, the vast oceans of space between the galaxies are expanding, but locally, gravity remains the undisputed king. We were told to imagine the expanding universe as a stretching rubber sheet with coins glued to its surface. The rubber sheet stretches indefinitely. The distance between the coins grows exponentially, but the coins themselves do not stretch. The internal structural integrity of a galaxy, a solar system, or a human body is bound by forces infinitely stronger than the baseline cosmic expansion. The Milky Way and our nearest galactic neighbor, Andromeda, are locked in a gravitational dance so intense that they are actively ignoring the expansion of space altogether, hurtling toward a titanic collision billions of years from now. The local neighborhood, the scientific consensus assured us, was forever safe from the tearing of the void. Phantom energy violently revokes that safety. If the equation of state parameter, the mathematical ghost we call $W, permanently sinks below -1, the repulsive force of the vacuum ceases to be a benign background phenomenon. It becomes a localized, escalating infection. Because a phantom energy field inexplicably increases in density as space expands, it will eventually generate enough localized repulsive force to overcome the gravitational binding energy of any physical structure in existence. It is not just pushing the coins apart on the rubber sheet. It is actively infiltrating the dense, metallic lattice of the coins themselves and tearing them to microscopic pieces. This apocalyptic scenario is known in theoretical cosmology as the Big Rip. It is not a sudden, unpredictable explosion. It is a timeline of systematic, escalating unbinding, a precise mathematical countdown to the agonizing death of structure itself. The unraveling begins on the grandest scales of the cosmic architecture. Currently, the universe is strung together in a vast, luminous web of dark matter filaments, with colossal superclusters of galaxies pooled at the intersections. Our own Milky Way is just a microscopic, drifting speck in the outer suburbs of the Laniakea supercluster, a titanic, sweeping structure containing 100,000 galaxies bound by mutual gravitational attraction. But in the timeline of the Big Rip, as the phantom energy field steepens its roll down the cosmological hill, these superclusters are the very first casualties. The invisible, ancient threads of dark matter will be stretched far beyond their elastic limit. Millions of years before the end of time, the Laniakea supercluster will silently dissolve. The galaxies within it will stop drifting toward each other, stall in the dark, and then be violently ripped away into the darkening void, isolated forever in their own lonely, rapidly expanding bubbles of empty space. But the phantom field does not stop at the distant borders of the galaxy. It continues to compound. It continues to aggressively feed on its own expansion. Fast forward through the dying eons, the escalating negative pressure of the vacuum finally reaches the threshold of the galactic scale. The Milky Way is held together by the immense, combined gravity of hundreds of billions of stars and the supermassive black hole, Sagittarius A*, anchoring its chaotic center. For billions of years, this localized gravity easily swatted away the weak outward push of the vacuum. But under the suffocating regime of phantom energy, the vacuum pushes back with exponential, devastating force. The outer spiral arms of our galaxy, where gravity's grip is the absolute weakest, will be the first to shear off. Billions of ancient stars will be unceremoniously stripped from their orbital paths and flung outward into the freezing, empty, intergalactic desert. The phantom pressure will relentlessly eat its way inward, dismantling the Milky Way layer by layer, much like a dying flower losing its petals in a Category 5 hurricane. Eventually, the dense core itself will unbind. The supermassive black hole will lose its captive accretion disk, and its chaotic swarm of companion stars, left to starve alone in the absolute dark. The great, swirling island universe that birthed our solar system will simply evaporate into the expanding black. If human descendants, or any advanced form of sentient life, still exist in this distant, terrifying epoch, their night sky will undergo a horrific and irreversible transformation. The dense, glowing river of the Milky Way that guided our ancestors across the oceans will slowly dim, fracture, and vanish. The heavens will be wiped completely clean. To fully grasp the claustrophobia of this era, you must understand the mechanics of the cosmic event horizon. As the expansion of the universe violently accelerates, the distance at which space is receding from us faster than the speed of light gets closer and closer. The boundary of the observable universe is not a static wall. In a phantom energy scenario, it is a shrinking cage. The event horizon will aggressively rush inward from billions of light years away, swallowing distant galaxies, then neighboring galaxies, and finally the local stars. The sky will not just be empty. It will be mathematically cut off from the rest of reality. The universe will shrink to the claustrophobic borders of a single, isolated solar system, surrounded by an impassable wall of impenetrable black. And then, the phantom field will breach those final borders. Months before the mathematical end of time, the expanding vacuum will become so viciously dense with repulsive energy that it will overpower the immense gravity of the Sun. To understand this localized destruction, imagine a massive industrial centrifuge spinning faster and faster, completely out of control. The planets, bound by the fragile, invisible tethers of solar gravity, will suddenly find those ancient tethers snapping. Neptune and Uranus will be violently ripped from their orbits, hurtling off into the deep dark. Jupiter and Saturn will follow, their massive gas atmospheres beginning to boil away into the expanding vacuum. Then Mars, finally, the Earth. Our world will be unmoored, cast adrift, flying blindly away from the dying fire of the Sun and plunging into a permanent, cryogenic night. But the true terror of phantom energy is that there is absolutely no bottom to its depth. It is a fractal of destruction that scales infinitely downward into the microscopic. It is not content with merely separating the planets from the stars. It must separate the atoms from each other. In the final hours of the universe, the relentless phantom pressure will overpower the electromagnetic forces holding solid, tangible matter together. The structural integrity of the Earth's tectonic crust will catastrophically fail. The planet will not simply crack or fracture. It will explosively disassemble from the inside out. The towering mountain ranges, the frozen ocean beds, and the dense, molten iron core will shatter into billions of isolated, drifting boulders. Minutes later, those massive boulders will shatter into gravel, and that gravel will instantly disintegrate into a fine, drifting dust. If you were miraculously standing on the surface in that final hour, gravity would cease to hold you to the ground, but you would not float away into the atmosphere. Your own biological body would lose the fundamental ability to maintain its chemical bonds. The complex, intricate biology that defines human consciousness would unweave, instantly dissolving into a chaotic, expanding cloud of isolated, independent molecules. In the final, blinding fractions of a second, the phantom field reaches the absolute, foundational bedrock of reality. It enters the quantum realm. The repulsive pressure of the vacuum becomes infinitely greater than the strong nuclear force. The unbreakable, localized glue of the gluon field that binds quarks together to form protons and neutrons. The atomic nucleus itself is forcefully, violently torn apart. And then, in the final, immeasurable instant, the fabric of space-time itself fails. The mathematics of general relativity dictate a horrifying singularity, a moment where the scale factor of the universe reaches infinity in a finite amount of time. The physical distance between any two mathematical points in reality becomes infinite. Space tears open, completely unzipping the very dimensions of length, width, depth, and time. This is not the heat death of a slowly cooling, aging universe. This is a violent, engineered execution of physical law. The revelation locked inside the bizarre, Desynchronized data streaming from the James Webb Space Telescope forces us to confront a terrifying philosophical paradox about the very nature of time and existence. For centuries, we have perceived time as a forward-marching arrow, dictated by the relentless, irreversible increase of entropy. We believed that reality was a stable, enduring stage, slowly decaying over trillions upon trillions of years as stars calmly burned through their nuclear fuel. White dwarfs faded into black cinders, and black holes slowly evaporated through Hawking radiation into a quiet, infinite sea of dead photons. We believed the universe would die a quiet death in its sleep. But a mutating vacuum, a universe infected by phantom energy, rewrites the entire definition of the future. It means the physical stage itself is collapsing while the play is still being performed. It means that time is not an endless, stretching runway into the dark. Time has a hard, mathematical wall rapidly approaching us. When we look at the undeniable discrepancy between the ancient cosmic microwave background and the violent supernova of the modern era, we are not just looking at a misaligned equation or a calibration error. We are looking at the telemetry of a runaway train. The acceleration of the universe is not a benign, background curiosity for academics to debate. It is the active, mechanical destruction of the future. The very laws of physics that allowed matter to clump together in the primordial dark, the delicate, perfectly balanced atomic forces that allowed carbon to form in the suffocating hearts of dying stars, and the precise gravitational choreography that allowed the Earth to maintain a stable, liquid water. Orbital of it is a temporary, unbelievably fragile anomaly. We thought we lived in a universe that tolerated complexity. We naturally assumed that life, intelligence, and structure were the ultimate, evolving goals of the cosmos. But the accelerating dark energy, the shifting, mutating ghost in the cosmological machine, suggests a far more chilling reality. Complexity is an aberration. The universe does not want stars. It does not want the sprawling architecture of galaxies. It absolutely does not want the intricate, delicate mathematics of biological life. It wants absolute, unyielding emptiness. It wants to aggressively sterilize the geometry of space, ruthlessly scrubbing away every speck of matter, every echo of ancient light, and every trace of physical structure, until absolutely nothing remains but the blinding, infinite expansion of the void. The true horror of the James Webb Space Telescope's data is not merely mathematical, it is deeply, profoundly personal. We are a species that has defined our entire existence by the act of building. We construct monuments to outlast our fragile bodies. We carve our histories into digital stone, and we beam radio waves into the deep dark, desperate to leave a permanent, undeniable scar on the fabric of reality. We naturally assumed the universe was a vast, enduring canvas waiting for our brushstrokes. But a cosmos dominated by a mutating, accelerating dark energy is not a canvas. It is a relentless, uncompromising eraser. It is a hostile architecture that inherently rejects the concept of legacy. The structures we build, the sprawling interstellar civilizations we dream of, and the delicate, improbable biological complexity that allows us to comprehend the stars in the first place are not the culmination of a grand cosmic design. They are a brief, accidental rebellion against an overwhelming, fundamental law of nature that ultimately mandates absolute isolation. We find ourselves living in an impossibly narrow, vanishingly small sliver of cosmic time. We exist in a fleeting cosmological twilight. The sky above us is still illuminated by the fires of billions of ancient galaxies, and the faint cooling echo of the Big Bang still rings clearly in our microwave detectors. We are uniquely, agonizingly positioned in the timeline of eternity to actually see the grand, sweeping architecture of the universe, to measure the velocity of its expansion, and to deduce the horrifying mechanics of its impending demise. If biological consciousness had evolved on this planet just a few billion years later, the phantom energy field would have already pushed the neighboring galaxies permanently over the cosmic event horizon. The night sky would be pitch black, devoid of distant nebulae or alien island universes. Our descendants would have looked up, seen a terrifying, empty void, and mathematically assumed that our tiny, fading solar system was the only physical matter that had ever existed. We are burdened with the heavy privilege of seeing the cosmic tragedy unfold, knowing exactly what is being stolen from us with every passing second. There is a distinct, agonizing beauty in this realization, a cold comfort in the absolute scale of the destruction. The universe does not owe us an audience. It does not mourn our passing, and it certainly does not owe us an eternity. The phantom pressure lurking in the absolute vacuum is not acting out of malice or vengeance. It has no intent, no consciousness, and no memory of the worlds it unbinds. It is simply a cold, unfeeling, mathematical engine grinding relentlessly toward its inevitable, infinitely sterile conclusion. We are nothing more than a temporary, highly improbable arrangement of stardust, momentarily granted the terrifying capacity to look back into the abyss and understand the exact mechanics of our own erasure. Look up at the night sky one last time, beneath the comforting illusion of that serene, ancient vault. The physical distance between the stars is quietly, violently growing. The invisible fabric of reality is stretching, accelerating, pulling the dark ever tighter around our tiny, fragile oasis. We are stranded on a microscopic rock, circling a dying spark, plunging blindly into an ever-expanding, suffocating night. The cosmic engine is racing faster. The infinite horizon is aggressively closing in, and eventually, the last of the light will simply give out,